Today, we will be talking about the law of Boyle's, Charles, and general gas law. The law of Boyle's, Charles, and the general gas law. Introduction. Boyles, Charles, Graham, and Dalton studied the physical behavior of gases. Gay-Lussac studied the chemical behavior of gases. Number 1. Boyle's law. It states that the volume of a given mass of gas is inversely proportional to its pressure, provided that temperature remains constant. We can see the graph here where P is decreasing as V is increasing. P stands for pressure, V stands for volume. Boyle's law deals with the relationship between volume of a gas and its pressure when temperature is constant. V is proportional to 1 over P. V is equals to K over P. Vp is equals to K. V is equals to volume, P is equals to pressure, and K is equals to constant. Mathematically, P1V1 is equals to P2V2. P1 is equals to initial pressure. P2 is equals to final pressure. V1 is equals to initial volume. V2 is equals to final volume. Boyle's law can thus be represented graphically. As the volume increases, the pressure decreases. Also, as the volume here increases, we can see the pressure as well decreases. Here, the volume is directly proportional to 1 over P, while here the volume is inversely proportional to P. Number 2, Charles' law. Charles discovered that the volume of a given mass of gas will increase or decrease by 1 over 273 of its volume at 0 degrees Celsius for every 1 degree Celsius rise or fall in the temperature, provided that pressure is constant. If volume is 273 meter cube at 0 degrees Celsius, its volume will be 272 at minus 1 degree Celsius. 0 meter cube at minus 273 degrees Celsius. That is, the gas will vanish completely. This is not possible since the gas would have liquefied at this temperature. This temperature at which the volume of the gas will theoretically reduce to 0 is called absolute zero. 0 degrees Celsius equals 273 Kelvin. Minus 273 degrees Celsius equals 0 Kelvin. To convert from degree Celsius scale to Kelvin, Kelvin equals degrees Celsius plus 273. Charles' law states that the volume of a given mass of gas is directly proportional to its temperature, pressure being constant. This can be represented diagrammatically. Thus, as the volume increases, the temperature increases. Charles' law can also be represented graphically, that as the volume increases, the temperature increases. And at the temperature of minus 273 degrees Celsius, the volume becomes 0. Therefore, V is proportional to T. V is equals to KT. K is equals to V over T. Mathematically, V1 T1 is equals to V2 T2. General gas equation. The volume of gas depends on temperature and pressure. Volume is proportional to 1 over pressure, and that is Boyle's law. Volume is also proportional to temperature, and that is Charles' law. Volume is proportional to 1 over pressure multiplied by temperature, or PV over T equals K. P1V1 over T1 is equals to P2V2 over T2. The general gas equation can be used to find the volume of a gas when both its pressure and temperature change. V2 will be equals to P1V1 T2 all over T1 P2. Exercise number 1. An increase in the pressure exerted on a gas at a constant temperature results in A decrease in the number of effective collisions, B, a decrease in volume, C, an increase in the average intermolecular distance, and D, an increase in volume. The answer is B, a decrease in volume. This is because the volume of a fixed mass of gas is inversely proportional to its pressure, provided that temperature remains constant according to Boyle's law. Exercise number 2. From the diagram above, an ideal gas can be represented by A, M, B, N, C, K, and D, L. The correct answer is option B, which is N. It can be seen from this graph that this line, N, represents the correct relationship between PV and P. Exercise 3. The volume of a given gas is V centimeter cube at P millimeter mercury. What is the new volume of the gas if the pressure is reduced to half at constant temperature? A, 4V centimeter cube, B, 2V centimeter cube, C, V over 2 centimeter cube, and D, V centimeter cube. The correct option is B, 2V centimeter cube. And this is because as the pressure is increased by 2, the volume is decreased by half. And as the volume is decreased by half, the pressure is increased by 2.